Let's go now to chapter 4. You are going to learn here a few more tricks about differentiation. You are now going to be able to differentiate more things than what you already know. And our first lesson, we are going to focus on two rules, the product rule and the quotient rule. This will allow you to differentiate functions that are more complex but can be broken down into simpler functions. So let's say that you have a function that can be expressed as the product of two smaller functions. You will be able to differentiate this by applying this rule over here. It's actually very simple. So if you have a function that can be represented as the product of two smaller functions u and v, if you want to differentiate it, what do? You just write the second function times the derivative of the first plus the first function times the derivative of the second. This is more easily explained with an example, so let's look at this. Right now, you look at this function and you don't know how to differentiate. But applying that rule, everything is going to be simple. How? Well, just identify first what the two smaller functions are. And you have 20x, and you have x minus 1 to the power of 6. So you already identified them. Your u is 20x, your v is x minus 1 to the power of 6. And now differentiate each one of these using the rules that you already know. So if you differentiate this is just 20. And if you differentiate this, you can apply the chain rule. In this case, it's going to be simple. It's just 6 times this stuff to the power of 6 minus 1, which is 5, times the derivative of what you have inside, which is just 1. You don't bother writing. So you already have everything that you need to apply that. So dy dx is going to be the v, which is x minus 1 to the power of 6, times du by dx, which is 20, plus u, which is 20x, times dv by dx, which is this stuff over here. Now just combine things that need to be combined, and always factorize the result, because chances are that you are going to use this rule as part of a wider exercise. That could be, for example, one that asks you to get the points at which the derivative is 0, for example. In which case, if you have the result already factorized, it's much easier to solve. If you equal this to 0, you have either this equals 0 or that equals 0. It's going to be much simpler for you to solve. What about the quotient rule? The quotient rule, as the name suggests, is a rule that allows you to differentiate a more complex function that can be expressed not as a product, but as a quotient, a ratio of two smaller functions. In this case, you have to apply this rule over here, all right? So now the two smaller functions is the numerator and the denominator of this fraction. If you want to differentiate the whole thing, then you apply this rule that says that the derivative of the whole thing is the denominator times the numerator, the derivative of the numerator, minus the numerator times the derivative of the denominator, divided by the denominator squared. Okay, here you don't differentiate anything, you just write whatever you have there, squared. Again, let's look at an example. This function over here. First of all, identify what is what. Your u is this, your v is that. Now differentiate both. This is just 2x, that is just 3. Now apply the rule. This rule, your v is that, times du dx, which is 2x, minus your u, which is this, times the dv by dx, the 3 over here, divided by v squared, which is over there. Now it's just a matter of simplifying. Expand brackets, put like terms together, and that's what you get. All right? I guarantee that sooner than you think, probably already today if you start doing questions right after this lesson, you'll know this formula this formula by heart, but you have them on the MF19 anyway. Let me see where they are. Here you have them. I know this is the, I know they are here, okay? The product rule and the quotient rule, all right? But I guarantee that you'll know this by heart very, very, very soon.